I'm Carol Ann Riddell, and this is Science and You. Today we're talking about our home, planet Earth, a place both familiar and wildly undiscovered for most of us. We begin with water. It is central to our existence, and yet in many ways our oceans remain largely unexplored, even though they produce 70% of the Earth's oxygen, and billions of people rely on oceans for their livelihood. Fabien Cousteau, grandson of legendary ocean explorer Jacques Cousteau, wants to change that with an ambitious project to raise awareness, living in an underwater marine laboratory for 31 days. He spoke to our Vianara Vinca about the experience.
I'm glad that we all came out of it in one piece. There were a lot of uncertainties. This was a theory, really, the project itself, as epic as it was, and based on real science and history as it was, still was a theory. The theory was, let's do this crazy mission and see if people are still interested in the oceans.
Dubbed Mission 31, the endeavor took place 9 miles off the coast of Florida Keys and 63 feet below the ocean surface, where Aquarius, the last existing underwater marine research lab, or underwater human habitat, sits on the ocean floor.
In history, there have been habitats built, certainly first by my grandfather and others in the 60s. There were several dozen in history. In the 80s, things changed and underwater habitats disappeared. And I think that's a huge travesty because we've explored less than 5% of our oceans.
Since then, even with underwater exploration technologies continuously evolving, Fabien Cousteau says there's nothing like living in an underwater human habitat and being able to explore the marine environment firsthand.
A habitat immerses you in the environment, and you become very tactile, and your senses are very much attuned to that environment, which is invaluable when you're trying to assess things.
We're going to do a test. Where's your EGS valve? Steady flow valve. Good to go.
I picked some young, aspiring marine biologists to be able to encompass a nice, rounded team that could give a foray into robotics engineering, into marine biology and science in general, so that we could get a good picture of what the next generation of ocean explorers and aquanauts could be.
Welcome to your new home.
Thank you. Good to see you.
This is our scientist, this is one of our technicians, and they're going out to one of our sites to bring some of the seagrass to plant around there's a seagrass right there, to put around where the predator-prey fear behavior models are. And we were studying the effects of the absence of predators on the coral reef with regard to biodiversity. And that really goes into the subject of overfishing and how we're taking away a lot of these essential creatures that make coral reefs healthy.
Now we actually just got back from the dive, hence the wet hair, and it went really well. It took us about maybe 45 minutes to set up the camera. We're using a lens that has a really narrow focus so we can see the details of these little critters.
No, don't move the camera. Just let me know when he spits so I can push the trigger.
Okay, I'll let you know.
But after 45 minutes, we got it.
There's a lot of critters that just move really fast, and only with the camera can we see the details of their movements.
So it was a pretty good day and all.
Really great day.
High five.
Yeah!
We were able to do over 3 years of science in 31 days. And that in itself was invaluable.
Here we go, end of Mission 31 Alpha.
After spending a full month at the world's final frontier, as Cousteau likes to call the underseas, coming back on land was yet another challenging experience he had to brace up for.
It was a bit of an unraveling experience. For the last 7 days of Mission 31, I was dreading coming back up because I had gotten so used to being underwater in the world's only undersea marine laboratory. It became my home. and fish became our neighbors, and we became very accustomed to what that meant.
I'm torn. I'm really happy to be back up this surface to see friends and family. I'm a little sad to be leaving our home from the last month, but it's pretty awesome.
For Science and You, I'm Vianora Vinca.
Gray whales have not inhabited the Atlantic Ocean for the past 300 years. However, in the past 5 years, sightings in bodies of water connected to the Atlantic have led scientists to speculate these whales may be migrating through melting ice in the polar regions. Andrew Falzone tells us more.
As a population, gray whales in the Atlantic went extinct several hundred years ago.
Dr. Howard Rosenbaum directs the Ocean Giants program for the Wildlife Conservation Society. Measuring upwards of 50 feet in length and up to 40 tons in weight, gray whales are some of the largest animals alive today. These gigantic creatures live in the Pacific Ocean in two distinct groups.
So the gray whales off the coast of Russia are called the western gray whales, and they are a highly endangered population, genetically distinct from the animals that are called the eastern North Pacific gray whales, for which there's a good census and recovery laws such as the U.S. Endangered Species Act, the Marine Mammal Protection Act, have promoted the recovery of those animals from very low numbers several decades ago to more than 25,000 animals in the population today.
But in 2010, this video stunned whale researchers across the globe. It shows a gray whale swimming off the coast of Israel. Then in 2013, another whale was spotted off the coast of Namibia in Africa. The scientific community was so surprised by the photos, many thought they were fake. But after they were authenticated, scientists began to hypothesize. They thought climate change might be part of the equation.
Now, as we consider what's happening with climate change and leads opening up in the Arctic and animals being able to move through the Arctic, in particular ice-free zones, that these animals may migrate from the Pacific to the Atlantic.
Phylogenomics is the study of using DNA to reconstruct evolutionary relationships between organisms and between species.
Dr. Liz Alter is an assistant professor of biology at the City University of New York's York College and Graduate Center. She's part of the team that used DNA to examine whether or not the now extinct Atlantic gray whales migrated from the Pacific Ocean. Prior to this study, there was no known genetic information on Atlantic gray whales. Sources of Atlantic gray whale DNA are hard to come by and show how science can come from some very unusual sources.
So occasionally fishermen who are trawling the North Sea will pull up a big chunk of whalebone, and if they don't feel like throwing it back overboard, and if they're a little bit curious about it, they'll bring it back, and then eventually it makes its way to a museum, and then eventually to us where we can extract DNA from it and sequence it.
This allowed Alter to confirm that the now extinct Atlantic gray whales migrated from the Pacific to the Atlantic during warmer periods about 10,000 years BC. They realized that climate change has created similar conditions.
We all started to wonder, okay, well, why is it that gray whales are showing up in the Atlantic now after this long hiatus? And of course, the immediate thing that everyone starts to think about is the decline in Arctic sea ice.
Since certain polar regions have experienced significant ice melt as a result of climate change, scientists believe that the whales were able to pass into the Atlantic, but caution it doesn't mean the climate change is a good thing.
Just because climate change is in essence facilitating a movement of one population to another does not mean it's positive. In fact, there are really Arctic-dependent species that will suffer due to warming seas.
I'm Andrew Falzone for Science and You.
As you can see here at Inwood Hill Park, even we urban dwellers are surrounded by nature. Our next story is about the struggle between the natural world and the man-made one. Our Tina Beth Pena sat down with Ted Steinberg, author of Gotham Unbound.
Greater New York's one of the most altered environments on the face of the earth. It's not an accident that Manhattan today is some 1,700 football fields larger than it was estimated to be back at the time that Henry Hudson came to visit in 1609.
How did New York City become one of the most dramatically transformed pieces of land in the world?
Back in the 1680s, when the British created a market in underwater land into something that could be bought and sold, just like anything else. The British colonists paved the way for the enormous expansion of New York at the expense of the sea. Another major turning point in New York's environmental history happened in the middle of the 19th century when the city turned to sources of water located outside the local environment. First, they turned and tapped the waters of the Croton watershed, and then the powers that be went on to conquer the waters of Catskills and the Delaware. By turning to outside sources of water, one of the byproducts of this is that they could now pave over the natural features of the land with brooks, springs, ponds to supply the inhabitants of Manhattan with water. And this incredible natural density gave way to enormous unnatural density, by which I mean instead of oysters, now you had all these human beings jam-packed into the New York metropolitan area. 19 million people stuffed into less than 1% of the land area of the United States.
So then what happened to those natural inhabitants?
What happened to the oyster reefs and the marshlands? They were filled in as part of this major reclamation process that was going on here to make way for real estate, roads, parks, and of course airports. I mean, if you take a look at a place like Jamaica Bay, as late as 1900, there was about 2,500 square miles of marshland there. By 1910, the amount of marshland in Jamaica Bay had been reduced to about 3 square miles. And the same thing went on throughout the other major salt marsh complexes throughout the New York metro area.
The decision to transform the waterscape and landscape to accommodate 6% of the nation's entire population has had several serious implications for New York City.
New York has been thumbing its nose at the sea for some 300 years. And now the city is confronted with global climate change, with the prospect of increasing sea level. The mid-range prediction is that by the middle of the 21st century, sea level around New York is going to increase anywhere from 11 to 21 inches. New York is on a collision course here with disaster, and in particular with respect to the issue of coastal flooding. Hurricane Sandy in 2012 was most certainly a wake-up call. According to the Federal Emergency Management Agency, some 400,000 New Yorkers living in the 100-year floodplain with a 1% risk of flood in any given year. That's more people living in the floodplain with the risk of being swamped than in any other city in the United States, including New Orleans.
Do you think there's a chance or any possibility sometime in the future that Manhattan may go back to what it once was?
Well, it already did. That's what happened during Hurricane Sandy. Manhattan returned for a brief moment to the watery world from which it emerged. It's important that we have some understanding, given the pace of urbanization, as to what the ecological ramifications are. This idea of New York as an infinite proposition really takes off, and it continues to shape and guide New York's relations with the environment to this very day.
We live in and with nature, but its power over us can be both awe-inspiring and tragic, from volcanoes and earthquakes to hurricanes and tornadoes. One thing we can do, try to understand the science behind those natural disasters. Despite all our progress as people, the enormity of nature's power can overwhelm us, perhaps no more so than when we face natural disasters. A current exhibition at the American Museum of Natural History captures exactly that. Called Nature's Fury, the Science of Natural Disasters, it is an in-depth look at the potential danger we live with daily.
Natural hazards are a consequence of us living on a dynamic planet, and there's no escaping them. Those risks will always exist.
Ed Mattei, the curator of Nature's Fury, explains learning about these disasters can help protect us.
Understanding the science is really important because it helps us determine the risk. You know, risk is really a combination of probability and consequence. So that's where science can help us.
Earthquakes, volcanoes, tornadoes, and hurricanes are all on display here, explained through the stories of people and communities, as well as interactive exhibitions. Visitors can stand in the eye of a tornado, create a virtual volcano, and even their own earthquake by jumping next to a seismometer. I'm going to make my own earthquake here. It's going to be huge. See that? Hurricane Sandy is also part of the exhibition, an example of Nature's Fury that many in our area are all too familiar with. The museum offers an interactive map exploring how New York City was vulnerable. Sandy demonstrates what some scientists tell us. Back in 2011, well before the storm, we brought you an interview with Professor Nicholas Koch, an expert on hurricanes, who said New York City could be hit hard.
We know that if something has happened before, it's capable of happening again. If it hasn't happened in a long time, it's going to happen soon. This right angle makes the New York area one of the most dangerous places in America for a hurricane to come in based on the generation of flood surge.
New York is one of the places that should expect pretty severe, pretty large hurricane every few decades or so.
So we are not out of the clear.
Well, there's no such thing as being out of the clear. There's such a thing as taking sensible mitigating actions, but there's no such thing as being out of the clear.
There is plenty of science here beyond hurricanes. The exhibit looks at plate tectonics, the theory of the movement of the plates that make up Earth's outer skin. And did you know that about 75% of all tornadoes take place in an area covering 8 states in the central U.S., known as Tornado Alley? And while some natural disasters strike with little warning, others can give scientists significant advance notice.
Volcanic eruptions are a different kind of hazard. We do have forewarning. Typically, we have forewarning of weeks to days to hours before eruption.
But science is only one part of the learning here, so is human loss and resilience. For example, Isaac Klein, a meteorologist in Galveston, Texas. The exhibit explains he warned of a hurricane in 1900 that killed thousands, including his pregnant wife.
These are human tragedies, and it's easy to forget that when we, wander through an exhibit like this that has a lot of, interesting things. But fundamentally, this isn't just interesting, it's also a tragedy. We can never forget that.
You still have time to check out Nature's Fury. The exhibition runs through August 9th. Finally today, the push is on to cool down the environment and reduce greenhouse gas emissions. And a city program is tackling that problem one roof at a time. Mike Gilliam has more.
During the summer months, rooftops like this can be steaming hot, and that can raise some serious issues. But one group of people is trying to change all that through a program called Cool Roofs.
It's a great program. And its goal is to sort of take out a heat source that's really, really widespread in this city and every city in the world, frankly.
Stuart Gaffin is a professor at Columbia University who also works for NASA. He says the principle is simple and something we all learned in second grade. White reflects the sun and heat, while dark colors absorb the sun's rays, causing surface temperatures to rise.
Because of that, the dark surfaces heat up tremendously, and I spend a tremendous amount of time on rooftops, and I've seen them reach temperatures up to 190 degrees and routinely exceed 170.
And with the roof painted white, what do you see?
So if it was about 80 degrees out, it would probably get up to 90, maybe 100. But you're easily shaving off 70 degrees Fahrenheit in that peak sunlight condition.
Gaffin says that can produce huge benefits when it comes to global warming and energy consumption. Former Con Edison sustainability manager Morgan Scott says the company has been on board for years.
The reason why we're putting and helping and involved in this program is because we really believe that our customers will see benefits. So when we put a white roof on a building and we reduce the building's temperature over time, we reduce the amount of energy that a building needs to consume to keep the building cool. So our customers are saving money.
Scott also points out the environmental benefits of the Cool Roofs program.
When you reduce the energy that's consumed, you have an emissions reduction on the back end. And so we like to see that with emissions reduction, you have improved air quality.
The program is run through the city and started off with a simple pilot program in 2009 in Long Island City. They wanted to see if cool roofs would be effective in New York.
Our goal was to coat 100,000 square feet of rooftop and at the same time work with the scientific community to do some initial analysis on what the benefits are of coating a roof white. And that pilot proved so successful that the city launched a full-blown program in 2010 with the goal of coating 1 million square feet per year in buildings all over the city to help the urban heat island effect that is a phenomenon in cities.
A heat island is a location that is hotter because it holds the heat. So far, according to the Cool Roofs website, more than 6 million square feet of rooftops have been painted. Now, that would be the equivalent of close to 120 football fields. The Harlem Congregation for Community Improvement has a number of buildings in the program, and they've seen roof temperatures drop.
The city was ahead of the curve on this initiative. They actually reached out to organizations such as HCCI, asked us to participate. We thought it was a great idea, and we participated and partnered over the 2-year period.
Over time, that should both cut energy consumption in the buildings, saving dollars, and it should also help to cool the areas, and in fact the city and the planet. Program organizers past and present say the Cool Roofs program works.
My message is that every roof should be white. This is a benefit to all New Yorkers, to every resident, everyone who lives here. It's very easy to do. Join us, come volunteer with us, coat your own roof, go to our website and see how you could become more involved.
So the experts agree a little bit of this special white paint and some elbow grease can help to cool down our city and do all of us a lot of good. I'm Mike Gilliam for Science and You.
Think about the size of New York City, millions of people. Now think about how much water we use. But where does all that water go once it heads down the drain? For most of us, it's out of sight, out of mind. Managing and purifying New York's water system is a massive undertaking, and the key might just be harnessing the power of tiny bacteria. Ari Goldberg explains.
I'm Ari Goldberg. Every day, New York City generates 1.3 billion gallons of wastewater. That's 474.5 billion gallons a year. Whenever rain washes dirt into the sewer, whenever you flush a toilet, take a shower, do the laundry, it ends up at one of New York's 14 treatment plants. It's an expensive and involved process, one that the city is trying to make more efficient.
We basically have been focusing on applied research, meaning that we're looking to solve real problems.
Professor John Philos and his team at City College have been tapped by the New York City Department of Environmental Protection to develop a cheaper and greener technology for the city's wastewater treatment. Specifically, the removal of excess nitrogen with a tiny bacteria called Anammox.
When you look at the nitrogen that originates from wastewater, it's in the form of ammonia and it's organic nitrogen. So when it's released into the environment, whether it's Jamaica Bay, Long Island Sound, when you go into an excess amount, this is when you create the problems.
It sounds almost counterintuitive at first. Nitrogen is an essential nutrient for life, after all. Conceptually, when we think of wastewater, we think of sludge and trash pollution, but nutrient pollution? However, it turns out when excess nutrients like nitrogen from household, industrial, and farming products end up in our waterways, they can disrupt oxygen levels, marine life, and our own drinking supply.
I guess in some way people say everything in moderation is good. So when we talk about removing nitrogen, we're not talking about reducing it to zero. We're reducing it to a level which will sustain biological activity in the waterways.
The goal is to turn these toxic levels of nitrogen chemicals, for example ammonia or nitrate, back into safe, pure nitrogen gas, which will escape safely back into the atmosphere. Conventionally, this process took massive amounts of energy and resources, but Professor Philos' team is harnessing the power of a bacterial family known as Anammox to do the work for them.
What we're doing is we're trying to find the most cost-effective way of doing it, which means the least amount of energy, the least amount of chemicals that you need. And what happens, what we have discovered is that this bacterial Anamax is capable of transforming the nitrate to nitrogen gas under anaerobic conditions with the minimal impact in terms of energy demand and in terms of chemical demand.
The Anamax family of bacteria is a relatively new find, having only been identified in the 1990s. Early applications began in Europe, but now the City College scientists are building that technology here, starting with small-scale reactors in the lab.
Basically, this is a bench-scale model of the reactor that is eventually going to be built to treat the waste stream. We start with basically a clean media, and the purpose of this media is to immobilize the Anamax bacteria by growing on its surface.
Anamax is a very slow-growing bacteria, and getting it to flourish on these plastic pieces was no easy task.
So that process of developing this biofilm on this clean surface took about 6 months. Okay? This is how slow the process is. And to tell you the truth, halfway through we began to become so frustrated that we thought that was never going to happen. But eventually it happened, and it worked very, very well.
The challenges we faced during the operation, which was specifically related to the wastewater characteristics in New York, that we didn't expect it in the beginning.
Despite these obstacles, once they had nurtured a population of Anamax, it was time to incorporate them into the waste treatment process. Masa Merdad is a PhD student working with Professor Filos.
So here on the screen we can take a look into the controls. Here in the summary we can see the temperature, pH, DO of the reactor, and also we can control the pumps. We can calibrate the system.
So as nitrogen waste is fed into the reactor, a critical mass of bacteria is now able to feed on that waste, converting it to harmless nitrogen gas, and in the process, cleaning our water. And the future looks promising for this technology, using less resources and costing less money than conventional methods.
Anamax for its growth doesn't need any external organic carbon, and the demand for oxygen also reduced by 60%. It is more sustainable and more cost-effective.
The next phase was to build a larger scale, a pilot unit, which we did this at the 26th Ward wastewater treatment plant. The project also has completed. It demonstrated the practicality and the cost-effectiveness of the process. And the City of New York is in the process now of putting together a request for proposal for a full-scale operation.
While this full-scale operation will still take a while to implement, thanks to Professor Filos' team and a tiny bacteria called Anamax, within the next few years we can expect all of New York City's wastewater treatment plants to be both more efficient and more environmentally friendly. From City College, I'm Ari Goldberg for Science and You.
That's our show for today. Join us next month for a fascinating look at engineering in our everyday lives, from your commute to your local Girl Scout troop. I'm Carol Ann Riddell. Thanks for joining us for Science and You.